Hi there. There are what I would consider to be 7 deadly sins when it comes to programming. Things that will grind your code quality into dust if you don't. That you should try this video to guide you to be never had to hear someone tell. Hi there. There are what I would consider to be 7 deadly sins when it comes to programming. Things that will grind your code quality into dust if you don't heed their lessons. Now, I hope you've never had to hear someone tell you that you write bad code, but if you have, there's really nothing to be embarrassed about. We all write flawed code as we learn, and the good news is, it's fairly straightforward to make improvements if you're willing. In essence, that's why I've created this video. Guide you to becoming a better coder. So let's look at the mistakes you might be making and see if we can fix them. The first thing I see people doing is not using programming standards. They give us rules to follow, like white spacing, file structure, and other philosophies that we apply to make our code consistent and therefore easily readable. It's also especially important when working with other people because it allows everyone to rely on shared expectations. If you don't keep standards, it's kind of like switching fonts all the time. We can read it, sure, but the subtle differences throw us off and slow us down a bit. As for choosing a standard, if you aren't given one by your team, then there's plenty to choose from in the wild. The second thing, programming design principles, are probably some of my favorite ways to improve. You can think of principles like a general guide into becoming a better programmer. They're the raw philosophies of code. Now, there's a lot of principles out there, too many to cover in this video, but I will quickly show 5 very important ones which go under the acronym of SOLID. The S in SOLID stands for single responsibility, and it teaches us that we should aim to break our code down into modules of one responsibility each. So, if we have a big class that is performing unrelated jobs, for example, we should split that up into separate classes to avoid violating the principle. It's more code, yeah, but we can now easily identify what the class is trying to do, test it more cleanly, and we can reuse parts of it elsewhere, without having to worry about irrelevant methods at the same time. This actually becomes more important as we progress. The open-close principle suggests that we design our modules to be able to add new functionality in the future without having to actually make changes to them. Instead, we should extend a module to add to it, be that wrapping it or something else, but we should never modify it directly. Once a module is in use, it's locked, and this now reduces the chances of any new additions breaking your code. Luckily, the luminous Liskov leaves us a lesson that loosely limits how we leverage our legacy code. Okay, that's enough of that. Liskov wants to tell us that we should only extend modules when we're absolutely sure that it's still the same type at heart. For example, we can probably extend a hexagon into a 6-pointed star, because that still makes sense as a 6-sided shape. But we can't really do the same if we wanted a 5 or 7-pointed star, because that would no longer be compatible with what a hexagon represents. It just wouldn't fit cleanly anymore into parts of your code that expect hexagons, and so it will have failed the principle. If that's the case, it should extend something that fits its design or become its own type instead. Almost at the end now, and we have I for interface segregation. It says that our modules shouldn't need to know about functionality that they don't use. we need to split our modules into smaller abstractions, like interfaces, which we can then compose to form an exact set of functionality that the module requires. This becomes especially useful when testing, as it allows us to mock out only the functionality that each module needs. Which brings me to Big D, which stands for dependency inversion. This one is pretty simple to explain because it says that instead of talking to other parts of your code directly, we should always communicate abstractly, typically via the interfaces we define. Dependency inversion breaks down any direct relationships between our code and isolates our modules completely from one another, meaning we can swap out parts as we need to. Because they communicate with interfaces now, they don't need to know what implementation they are getting, only that they take certain inputs and return a valid output. The cool thing about Solid is that when we combine all these principles together, it ends up decoupling our code, giving us modules that are independent of each other and making our code more maintainable, scalable, reusable, and testable. Programming design patterns, not to be confused with principles from the last chapter, are also something I see underused a lot, when they really should have more of a place in your mind. And a valid output in your mind. Patterns give us some real solutions to our code problems, but they aren't fixed implementations, so they're still kind of open to interpretation. We use them to architect our software systems, matching the right shapes to fit the needs our software has. First up, we have creational patterns, which are there to help us make and control new object instances, such as the factory method pattern, which turns a bunch of requirements into different modules that follow the same interface, but aren't necessarily the same type. Then there's structural patterns, which are concerned with how we organize and manipulate our objects, such as the adapter pattern, to wrap a module and adapt its interface to one that another module needs. Finally, there's behavioral patterns, which focus on how code functions and how it handles communication with other parts of the code, such as using the observer pattern to publish and subscribe to a stream of messages in an event-based sort of architecture. Now there's a bunch of different design patterns under each category. Some of them you might have used before. A lot of these patterns are the way you name things, which make it harder to read instances of the code. If you haven't, and that's understandable, I think. Writing tests can be very difficult when code is not properly architected. At the high level, we have end-to-end testing, which lets you test the system as if you were the end user. It's useful because literally any spaghetti code can be end-to-end tested, assuming you can code is doing what we expect. As you learned, automation is should take my own advice. It feels excessive, but it's impossible to predict time and how you manage it. Time estimation is a process I still fail in sometimes. A common rule of thumb is to double or even triple your initial time estimate for a task. It feels excessive, but it's impossible to predict the unknown problems we will encounter along the way, so we need to account for those. For example, this video took 3 times as long. Remember that creation goes hand in hand with it and deliver ahead of schedule than it is to miss a deadline. I wanted to say decisions right first time, but we can at least give ourselves, and hopefully are likely to finish to rush, projects that get. I'd like to end end with a quote from Martin Fowler. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. Thank you so much for watching.
Second channel, but I saw in this article, we'll see how interesting it is. We'll see if I agree or disagree with the person, but basically basically a former Google manager says the tech giant is rife with fiefdoms and the creeping failure of senior leaders who weren't making tough calls. I already somewhat agree with this title, but what does that word mean? Estate of land? Feudal service? A person's sphere of operation or control? I'm guessing that's just another way of saying bureaucracy. Former Google manager said senior leaders allowed the company to be filled with small, I'm just going to start saying kingdoms instead of this word. There's like a saying that I'm not super familiar with, but people say like in the corporate world, there's this thing called empire building, where as you get higher and higher into management, it's hard to quantify the work that you did. If you're like an executive and your org is doing really well or whatever, it's hard to say like how much of that is attributed to you. So the saying I've heard is that like at that level, they just try to hire more people. They try to make their org bigger and have more headcount and things like that, so that it looks like they have more influence. Because if they have 1,000 people in their report chain, it looks like they're really important, even if their org isn't that important. So I think that's what this is about. It makes sense when you have a company like Google over $1 trillion that there's a lot of waste. So let's see. John Bellack said Google was weighed down by mid-level managers debating decisions for months. Other former Google employees have previously criticized the company over management bureaucracy. I mean, we all know, and in case you don't, I used to work at Google. In my defense, I do use the brand name quite a bit. I'm pretty honest about my experience. I do criticize Google. I do say the negative things. I'm not trying to sell Google to anybody. I'm not telling anybody that they need to work at Google. People say I'm biased. Maybe I probably am, but I try not to be. So let's see if I agree with some of these criticisms. A former product manager. That's already a negative for me. I did not have a good experience with almost any of the product managers that I worked with at Google. Said the tech giant suffered from management bureaucracy filled with small kingdoms that weighed the company down over decisions that senior leaders failed to make. That's definitely PM on this project, and the tech lead startup was acquired. So he didn't have to pass any leak code. Interviews, and he criticized the management culture in a Threads post. Could have been Twitter. At least with Threads, you can read it without having an account. Let's see what he said. In my 15 years, I saw kingdoms a lot, but engineer was rarely the root cause, and PM was rarely the solution. Okay. And I think he was a PM, so he can't be biased against him. Data flow, it's like for big data processing. I never had a business need to use it. I probably wouldn't ever use this in a personal project together in the unknown. I think that makes sense. It's like analysis paralysis. When you're an executive or just even working at Google, it already makes so much money. If you're like the CEO of Sundar, and a lot of people criticize him because they say he doesn't do anything, but at the scale of Google, not doing anything and not messing anything up, like what another CEO is kind of known for, as long as you don't mess something up too.
It's no secret that big tech companies pay out compensation figures that aren't comparable to any other industry. Engineers fresh out of college are able to earn nearly $200,000. With just a couple of years of experience, they can up that to $300,000 to $400,000. And by the time they're in their 30s, they're often earning $500,000 to $1 million. These jobs also often come with a bunch of perks like unlimited paid time off, the ability to work from anywhere in the world, free food, stock in the fastest growing companies, and so on. If you ask the average person, the only real downside of working at big tech is that there may be some level of moral compromise. I mean, at this point, it's really no secret how a lot of these companies make money. Even when it's not straight up data collection or privacy intrusion, it's often monopolization, anti-consumer policies, and abusing of power. But this moral dilemma and quote-unquote selling out is only the tip of the iceberg. This is actually often the least of your concerns when it comes to surviving and advancing at big tech. The reality is that despite their inviting-looking offices and seemingly employee-friendly policies, working at big tech is much more like being a professional athlete. If you follow sports, you'll often hear about contracts that are worth tens of millions, if not hundreds of millions of dollars. But actually cashing in on the full value of these contracts is much easier said than done. Usually, half or more of these contracts are paid out based on performance. And unless you're able to keep up world-class performance for 5 to 10 years straight, you're only gonna walk away with a fraction of the top-line value. It's not that dissimilar at big tech. You get paid sky-high salaries. Team, not a family. A dream team is about pushing yourself to be the best possible teammate, caring intensely about your team, and knowing that you may not be on the team forever. Dream is given here's the truth about working at big tech. And before we discuss the inner workings of Netflix, I wanted to clarify it's largely made up of stock comp, and it's no wonder why they expect so much, and I'm not criticizing that by any means. Rather, I want to show how working at these companies is often not transparency. That is discussed behind not just their direct reports, but everyone at the entire company. And as for performance reviews, these are even more accessible. Everyone who is an admin or up has access to the performance reviews of everyone at the entire organization. You're probably thinking that this would lead to a lot of awkward conversations. You know, the whole always knowing how your peers are performing, and believe whether they would rehire and or fight for their direct reports. If the answer is ever no, it's time to fire them. And don't think that after receiving a bunch of negative feedback about curation, Netflix decided to fire their chief product officer that was responsible for the curation algorithm, Neil Hunt. This was despite Neil being a personal friend of Reed Hastings and an OG employee who Netflix does. That's how boss Bezos likes it. In fact, Bezos isn't a big fan of tenured employees because he thinks that people simply get more comfortable and lazier with time, leading to a march to mediocrity. As such, Amazon has a bunch of policies to constantly churn through employees, starting with PIPs or performance improvement plans. Every year, Amazon has a policy of hiring the bottom 10% of their workforce. This way, the quality of their workforce is always theoretically improving. In reality, this often just leads to a bunch of toxicity, office politics, and bad blood. In fact, it's common practice for Amazon managers to hire to fire, which is exactly what it sounds like. If you're an as they like to come off as the good work for it, even if it's because you got fired. With unlimited PTO though, there is no acquired PTO, meaning that there's nothing to cash out when you leave even though you barely took any vacation. They hire the most talented and competitive people in the world, and they dangle the opportunity to have even more power, money, and influence in front of them. I think you can guess what sort of environment this would lead to, the good cop model. But if this is the reality of working at and only 12% get a 1. In any industry, the payout is proportional to the expectations. With something like finance, the high expectations are evident to everyone. But believe me, they're literally and figuratively, and that is the true price of working at big tech. At least these companies pay massive salaries to compensate for that. Oh, wait, never mind. They're making moves to dramatically.
Open source is great, and you probably shouldn't contribute to it. I know, spicy take, y'all are gonna have some feelings about this one, but this isn't a clickbait video. I do actually believe that most developers probably shouldn't be contributing to open source, or at the very least, setting open source contributions as a goal. We're gonna take a bit of a weird journey, but I think it will highlight why I feel so strongly about this, and also help developers.
Hey! Don't contribute to open source. All right, emergency stream! Emergency! Something is going on that's a little bit wild here. Look at this. So this Anon 2.0 says, what kind of bullshit are these fuckers promoting in the name of open source, misleading people into making spam PRs in the main Express.js repo? Look at this. Update readme, update readme, update readme, update readme, update readme, update readme. Update readme, update readme. And look at this. If you go onto the Express.js, it is literally just update readme. Just non-stop. Hello, I am new to GitHub. Please accept my pull request. You can you can just compliment my text here. Smiley face. Damn, not only are you new, just let her cook for a second.
कोड के अंदर कर रहे होते हैं जैसे उन्होंने कोई गलती कर रखी है कोड के अंदर तो उसको हमने फिक्स कर दिया या फिर कोई नया फीचर हम उनके कोड के अंदर उनकी वेबसाइट के अंदर ना कॉलेज लिख दिया
Two, I'm to blame, but don't worry positives or negatives about being hard, and you really wish you had a job and you're open source PRs are the way to get noticed and prove that you can, oh my goodness, that you can literally a billion people. Like there are literally boot campers all flying out right now that exclusive to India. But India has a big population of devs of. Lane wrote this for me to read because he was like, yo, did not know that this was a thing. Lane! Gosh. Version ad infinitum. But evidence that the answer I'm looking for exists in the place I'm searching. I'm bailing pronto. We have a few dozen development.
Obviously, the software industry shortage. They also mention a fifth.
So, I've decided that it's time for me to start looking for a software job again. And with me starting my search, I've created 4 different parts: lead code, systems design, how to get software interviews, and how to improve my coding skills. And I will go through studying it in the past, although very inefficiently. And with that, these are the ways I'm going to ramp up my knowledge to my levels in 2020. The first thing I'm going to do is focus rigorously on the fundamentals, being data structures and algorithms first. And to do that, I'm going to be using the Neat Code 150 list. By the way, none of this is an ad if you were worried about that. But Neat Code 150 is one of the newer things to come out. It came out after my whole Leak Code studying process, and I've already done a little bit of it, and I gotta say, it's absolutely fantastic. It's exactly what any beginner needs to do all 150 questions while timing myself for every single one, and then mark the ones I struggle with or take a long time with and repeat them in order to commit them to memory or learn them properly. And while I'm focusing on the fundamentals, which is like Neat Code 150, I'm going to be practicing every single question with a framework I learned back in my 2020 days of studying Leak Code, using a technique called the ESTCV method. And what this method is a simple way to break down every single Leak Code question that you do. When you're interviewing for a job in real life, what's even more important than getting the right answer is to make sure that the interviewer actually understands what the hell you're talking about. Because I think my biggest problem in the past, before I studied Leak Code or before I learned these methods, was that an interviewer would just give me a question and then I would just sit there silently and then the interviewer would just be like really confused as to what I was, is to write down examples and clarify the interview question. It might seem a lot of software bad side kind of example for how you will tell you like, yes, this is acceptable, let's work. The third part is writing down test cases. This is where you want to write all different kinds of examples for how you will test your fully coded solution in the end. This is where you test base cases, this is where you test edge cases, and the point of this is with the test cases. This SCTV, I'm gonna go to Leak Code and look for medium or hard questions that I have never seen before, just to practice this feeling of being uncomfortable and just to simulate the environment of being like stressed out in an interview. Cool. So next is system, and once you're done and you have interviewer would just give me a question, do well. I have seen my friends avoid applying online as much as I possibly can. Instead, I'm going to be focusing on reaching out to my network situation is going, but I don't expect to jump into applying. Maybe no, I quit my job, coding software job, and I think all of this will be a fun challenge for myself. I think all of this will help me review a lot of web coding skills, and hopefully it will really help me to, re-spur this passion that I had for software engineering. So, that's my whole entire plan. Feel free to click over here to check out some of my other stories about my software life, my career, and just everything I've been doing. Subscribe if you want to follow along with my journey, and
if you're struggling with solving Leak Code questions,